now I screenshot. Okay. Um,
Yeah.
so
2.3.3 matrices.
here, there. Uh,
Just as vectors generalize scalars from order 0 to order 1, matrices generalize vectors from order 1 to order 2. Matrices, which we will typically denote with bold-faced capital letters, example bold capital X, bold capital Y, and bold capital Z, are represented in code as tensors with two axes. In math notation, we use capital bold A element of real R raised to m cross n to express that a matrix A consists of m rows and n columns of real valued scalars. Visually, we can illustrate any matrix A element of R m cross n as a table where each element Aij belongs to the ith row and the jth column. So A will be a matrix with elements A11, A12 to A1n changing row-wise, and A11, A21 to AM1 um, changing column-wise, and the last element will be AMN, that is m column and m row and n column. For any A element of R raised to m cross n, the shape of A is Mn or m cross n. Specifically, when a matrix has the same number of rows and columns, its shape becomes a square. Thus, it's called a square matrix. We can create m cross n matrix by specifying a shape with two components m and n when calling any of our favorite functions for instantiating a tensor. Can you change to PyTorch?
yeah.
Yeah. A equal to torch dot arrange 20 dot reshape 5 4. So here 20 elements will be reshaped in the form of a matrix with 5 rows and 4 columns. 0, 1, 2, 3, 4 columns, and 0, 4, 8, 12, 16, 5 rows. We can access the scalar element Aij of a matrix A in equireference equiref, EQ matrix if
It,
by specifying the indices for the row I and column j, such as Aij. When the scalar elements of a matrix A, such as in ref EQ matrix definition are not given, we simply use the lowercase letter of the matrix A with index subscript as small letter Aij to refer to the element Aij. To keep notation simple, commas are inserted to separate indices only when necessary, such as A2, 3j and a2i minus 1 2i minus 1 comma 3. Okay, so that is like a complex matrix a2 comma 3j and 2i minus 1 comma 3. Sometimes we want to flip the axis. When we exchange a matrix's rows and columns, the result is called the transpose of the matrix. Formally, we signify a matrix A's transpose by A raised to T, and if B is equal to A raised to T, then B small bij is equal to small aji for any I and j. Thus, the transpose of A in equivalent reference equimetrics definition is a n by m matrix. So here we'll have m columns and n rows. In code, we access a matrix transpose via the T attribute. So capital A dot T will be giving us the transpose of matrix A. As a special case of the square matrix, a symmetric matrix A is equal to its transpose. That is, A is equal to A transpose. Suppose we have 3 by 3 matrix with elements 1, 2, 3, 2, 0, 4, and 3, 4, 5. Then B dot, um, okay, this is a 3 by 3 matrix. 1, 2, the B dot T will also be the same. Correct, right?
Yeah, so if n equals m, then it's a symmetric matrix, or?
No, even the elements are similar here. You can check that. No? 1, 2, 3. If you transpose, like the first column has 1, 2, 3 elements. The first row also has 1, 2, 3 elements. Second row has 204. Second column also has 204. Third row has 3, 4, 5.
No, no,
Third
no.
column,
I mean, if n, like here, this is n. Wait, no, no.
I
Wait,
think,
wait, wait. Here, the if m equals n,
yeah.
then it's a symmetric matrix. Like if
No,
the
then it is a square matrix. Only if the elements are also equal, they become a symmetric matrix.
but the elements.
Here they are same, right? Just check like, where is it? Yeah, B. That, yeah, if you check here for B, first, just say first row elements are 1, 2, 3.
What do you mean? Which ones are the same?
In the matrix B, the rows, the first row elements are 1, 2, 3, right? The
Hmm.
first column elements are also 1, 2, 3. The matrix B.
Oh, you mean like this, and then
Yeah,
this.
and yeah. So
So like,
similarly, for the second row and second column, elements are same.
why can't I?
204, 20. Second row, 204.
Yeah, 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 I know. I just wish I could like mark
Yeah,
it, but it's not. It doesn't work with a Chrome browser. Okay, so this is equal, and this is equal,
the
and
next
then
row,
this and
204 and
this.
204. 345 and 345.
3, 4, 5. 1, 2, 3. Yeah. Okay, and then
So
this.
even if
Okay.
you transpose, you're getting the same matrix itself. There is no difference. So such matrices are called symmetric matrix. But only if
Okay.
m and n are equal, they are called square matrix.
Okay. Okay. So they define the transposition formally somewhere here.
Yeah.
Um, n times m, and here it's m times, here it's m times n, and here it's n times m, or
N times m. Yeah.
wait, where is it? Here,
Yeah.
n times m. Uh, but if this is um, why does it say here mn? It's the same as in the matrix definition here. Why doesn't it say nm here?
I think there, no. Can you go up, back?
Yeah.
Yeah, here it is. I think first one they made a mistake. No,
No.
mth column and nth row. Yeah, correct. Mth row and nth column. And down,
Yeah.
it should be nth. Yeah, they made a mistake there.
Here.
Because the first element, no, no. Uh, Actually, the instead of A1N, the element should have been AN1,
Yeah.
AN2, and then ANM. That whole thing they made a mistake.
Okay, so I will make
And like the second element should be A21
I will make a
instead of
comment.
A1. Yeah.
Um,
2.3.2
okay,
is that
figure 2. The fig like
2.3.3.
this. Yeah, will also include the. I think I can directly link to the figure. Uh, um, do you see something with an ID here?
No, they are giving only text style and 2.3.3, the
Oh,
class.
there's actually here. There's
2.3.3, it's a class. I think they have
see
mentioned.
there's like a, normally there should be a link there. Permalink this equation here, but somehow it's not visible. See, there's an A tag here in the source.
Do you think it will load when you see network or performance when you load the page?
No. I mean this A class here.
Yeah.
There's like no, like on the right hand side to this number there should be a link, but it's not like it's invisible because it has a opacity 0. See, now when I remove this style attribute here it appears, but it doesn't work. It still doesn't work. So I think that's why they make the opacity 0, because it doesn't really work. Weird. Oh, it has visibility hidden. Okay, so I will just use this. Sorry.
Maybe a
ID.
screenshot. Yeah, that one.
ID equation. Yeah. Stephen also wanted to join this group, right? Stephen, you replied
Yeah,
to him on the Google spreadsheet.
yes. So I think he wants to join for the uh, 90, not
Here.
90. Yeah, 19 hours.
Yeah. Okay. I think he's doing. I'm not sure if he's like he's testing the code or something. Um, okay.
I think Stephen will join in the no, 7 o'clock, and then we can tell him like this goes on
Oh, okay.
the clock. Okay, so
Yeah, I think we should. This one we should run until like 1 more half hour, and then we should make a break for half an hour.
yeah, we'll do that.
And yeah, okay. Mm, uh, okay,
Yeah,
so let me check what the. I think we should try out the transposing in the Colab because I don't really get
yeah.
it. I'm too stupid to get it ad hoc. Um, Let me check. How do I cycle through this?
First, we have to create a matrix A.
Yeah. What? Okay. Matrix
Matrix A.
A.
Actually, no, I don't agree with you because that arrange function, right? Arrange
Hmm?
and reshape. I cannot correlate it ad hoc even now. Like I've seen it many times, but it's very difficult for me. So matrices,
Why?
like because you give like 20 numbers and sometimes there will be two parameters like 20 comma uh, 30 and then divided into 10 metrics and then reshape into and that whole thing is little confusing for me.
Maybe you should start doing it in the Colab.
Yeah, I like, yeah, I should type more. Yeah.
I wish the team viewer thing would work, but you could also, you could also share your screen.
Only one person can share, but this is okay. I'm also doing
Yeah.
it in here.
So this is 1, 2, 3, 4, 5, 7. And then when I transpose it, I get 1, 4. Why 1, 4? Because then it's, oh, okay. So it's using columns as rows, right?
Yes.
Okay, I get it. Okay,
So
okay.
5, 4 became 4, 5. Dimension 5, 4 became 4, 5.
I think I will try this one. Let me check if I find it. You see this? I try to click in the search. I'm clicking multiple times here in the search.
Okay.
It doesn't work because it's like this on Mac. When I use full screen, I can't use Google. I can't
Okay.
go. I can't also change the address bar. Like I need to exit full screen mode for it to work.
Yeah.
So
Okay. Yeah,
mm,
that's because first you have to exit out of your um, Zoom.
no, it's not nothing related to Zoom. It's like even if Zoom is off. Um,
Oh, in the full screen it doesn't work.
so there's this Zettelkasten thing. I'm not sure because I thought with the like since I understood now how the transposition works, I should make myself like a flash card, you know,
Okay.
something I can learn later on. Do you know? Do you use any software for that?
No.
But there should be software for it, right? Um,
I'm more of a writing person. I keep notes, like hardboard notes.
I mean, like learning vocabulary. Um, um, make flashcards. I don't know. These all these websites are like I don't know. Hmm. This is not a phone input field. I hate when they do that. I can't use autocomplete for my number. Um, my classes. Um, dive into the linear algebra. And then, what is a good and simple explanation for matrix transposition? It converts the rows to columns and vice versa. Um, okay. Um,
Okay, so this dot t is a numpy function, right? It's not a torch function, it's a numpy function.
okay. Where does it say that?
Because I was trying to run t without numpy and then it didn't work.
Okay, but I didn't include NumPy here anywhere. Maybe
Uh,
Torch. Uh,
no, so okay, then it's a
maybe
torch function.
or maybe Torch is dependent on NumPy,
It could be.
or maybe it's also function in NumPy. I don't know.
1 minute, we'll just Google it.
A special type of, oh, and they also, where do they mention square matrices? Has the same number of rows and columns, its shape becomes a square. Thus, it is called a square matrix. Okay. I will also make flashcards for that. What is a square matrix? It's a matrix where M
Yes,
equals.
actually, yeah.
Um, what is a symmetric matrix?
It's a square matrix with all elements equal.
A square matrix with all elements equal, or
No,
with a,
where the A equals A transpose. So
yeah,
that is
it's a square matrix which is
whose transpose
equal to, it's a square matrix which is
equal to the
well,
transpose matrix,
to its transposition. Yeah,
which equals to
which is equal.
equal its.
See, the Grammarly is a bit bad because I would write it, which is equal to its transposition, but it recommends
Yeah, its transfer, which equals to its transposition. Even I'm more used to equal to its transposition.
which is equal. Yeah, the Grammarly, and also this, not its. No, it's like it's a
Yeah,
genitive,
it's a yeah
and then transposition. But there,
trans
I made a
transpose,
spelling.
correct? Transpose.
Okay,
I'm not sure if you pronounce it as transposition because I've only heard transpose.
okay. I,
POSC.
I I think you can say transposition. Let me check. Yeah, like I'm just, yeah,
Another
it's here. It says
mathematical
math.
term.
Here it says math. It's also known as a mathematical term.
Okay, then it's right. So about dot t is a numpy function, but PyTorch the function is dot transpose, tensor dot transpose.
Yeah. Sorry, can you repeat?
Yeah, so here we did a dot t, right? So this dot t is a numpy function, but if you want to do the same thing with PyTorch, it is
And tensors. Yeah.
tensor dot transpose. That word transpose is given.
Can I
TRA.
also can I also what about
Just can
what
instead of a dot t, can you type
what
transpose?
what about the three-dimensional tensor? Can I also transpose that?
Yes. So
Okay, so it also works for tensors. And then how does it work?
so like, can you make it TRA in instead of a dot t?
Sorry,
A
see?
instead of a dot t, just make
Yeah,
it TRANSPOSE transpose.
so here.
T yeah yeah. Just run that. Okay, so it created a No, like you don't need the bracket. Bracket is not needed. You can actually store it to another variable and then see and display it like no. Now you will have to go through each element like we use ij that you have to what do you say iterate through each element to see the um, elements. Got it?
Okay. I
So
can't iterate in Python.
like in Tensor now we'll have to iterate, but in NumPy it's like stored as an array, and that array is easily accessible. That difference I'm not. Do you get the difference? Like
I'm not really sure what transpose is a function received, and it got well expected one of it expects a dimensionality dim 0 or what?
no, again 5.5, maybe. No, no, 3, 4.
3
No,
comma 4. Oh,
yeah.
okay. Oh, okay. So, but why just 2 dimensions? Why just 2 dimensionality arguments? Like, why not more? Dimension out of range. Expected. I think this function is doing something else. Or like,
No, but here
where
torch,
did you get it from?
the torch documentation, this one. So here they say you can give an input tensor and first dimension of the transpose and second dimension of the transpose. It should be a M by N matrix.
Oh, so this is for the which axis? So I should be like a 0 and 1. Yeah, okay, I get it. Okay. So I can do like a matrix transposition in a tensor. For example, I
Oh,
also
okay.
say 1 and 2, and then I would then see then it transposed
Okay, the
all these.
in within inside they are transposed, like the
Yeah,
elements are being transposed.
yeah, and it's doing just a matrix. It's not doing more than 2 dimensions. But with
Okay.
a, I wonder how the t when I do it with on a tensor with 3 dimensions, it's doing a transposition across all 3 axes. I think so. It's doing 0,
Yeah.
12. So it's always taking the first element for the first.
I
Uh,
can give you an example here. Like if you consider
in
matrix A,
in yeah.
okay, matrix A is having consider this 0, 1, 2, everything are pixel values of 5 different pictures. Okay,
Mm-hmm.
if you want to just jumble the picture order, like fifth picture to first picture to second picture, then you can use a dot transpose.
Okay.
But if you want to jumble the pixel values within each picture, you have to use a dot t.
Okay.
Did you get it?
Okay.
Like
Yeah. Um,
so, these are like 2D.
partly like Yeah.
Or we'll take it as housing examples. Okay. Uh,
Yeah.
so each tensor will be
I think what would be good if you're giving me an example, I should be writing it down. Like then I can like a housing prices.
yeah. So in housing prices, we have four columns, or like location, then bedroom, number of bedroom, and what else can we give? Number of bedrooms, say porch, garage available or not, 0, 1. Okay, 3 rows. Okay, and
Okay.
this will have location. Suppose 3 is the location number. We are giving street number 3. Okay, number of bedrooms is yeah.
Okay. Yeah.
Okay, so um, now here, like 3, 3, 0, if you want to like jumble between location, number of bedrooms, and garage, the columns, then you will use dot
What does
transpose.
did you say jumper?
Yeah, like if you want to mix the um,
Okay. Yeah.
if you want to mix columns, like from make garage as first column and location as second column, like that, if you want to reorder the columns,
Mm-hmm.
we can use dot transpose.
So how will look afterwards? It will look like this. Uh, um,
No, this will be the result of dot t.
okay. So, but this is the transposing, right?
If you what I said is like dot transpose, you will have 0, 3, 3, 0 within the columns. They will change.
Wait, I will give you the link, then maybe you can show.
No, it's okay. Like I don't think that example is right. It can work with pixel examples, but then
Okay.
not with housing
Uh,
prices.
okay. Okay. But this is a good, like this is not a good example, but this is like how the transposing would work,
Yeah,
right?
yeah.
Okay. Um, okay.
So next we have to move on as a special. No, no, we didn't reach tensors. No, we were at tensors. No, no,
Um,
before this. Yeah, as a special type of square matrix, a symmetric matrix A is equal to A transpose. Matrices are useful data structures. They allow us to organize data that have different modalities of variation. For example, rows in our matrix might correspond to different houses, data instances, or data points. Yeah, we actually we were talking about it, right? It will correspond to different houses, like just we wrote there. While
okay, yeah.
columns might correspond to different attributes. This should sound familiar if you have ever used spreadsheet software or have read section 2.2. Thus, although the default orientation of a single vector is a column vector, a matrix that represents a tabular data set, it is more conventional to treat each data instance as a row vector in the matrix. And as we will see in later chapters, this convention will enable common deep learning practices. For example, along the outermost axis of a tensor, we can access or enumerate mini batches of data instances or just data instances if no mini batches exist. You got that?
I lost it at the mini batches.
Yeah. So what they meant is like, um, do you know about window functions in SQL? Like if there are, you'll say take a set of 4 columns and make it a batch or like a window, and
mm-hmm.
then you will stride to the next 4, then to the next 4. So it will be
Mm-hmm.
like, um,
Okay, but why mini batch? Why not just batch?
yeah. So when we are doing deep learning, we can there's a lot of data, right? Huge volume of data that is need to be trained. So if you are sending one batch of data to train at first, it will cost like it, that model may not be able to handle it, that volume of data. So they're trained in batches, like the first batch. It's just like there are 30 students in a classroom, and first 6 will get to use the lab first, then the next 6 will get to use the lab, like that, because the lab cannot um, accommodate all the 30 together.
Oh, but why? But I don't understand the naming. Why mini? Like, why not just call it batch? Why mini? Like, what's mini about it?
Because if you see some like we also read about conventional machine learning techniques, right? They are like suppose linear regression. Those data we can actually do it in one stretch. So they are called batches here. And when it comes to deep learning, we divide it like we have to divide, and we call it mini batch.
So is there
Every
also
time,
is
yeah.
there like batches and mini batches, like a chapter and a section, or is it like a is there just mini batch?
Yes, it's like a chapter and a section. Yes,
So
correct.
there's also batch, and then the batch is further subdivided into batches, mini batches.
In the mini batches, yes.
Ah, okay. And I
So,
think,
for
yeah,
example, like suppose we have medical data of, uh, or suppose the housing data itself. We have 2019 data, 2018 data, and 17 data. So 17 is one batch, 18 is one batch, 19 is one batch. Then further we divide into quarters that as mini batch. And you can combine all the mini batches from 17, 18, 19, and together run it as a mini batch.
okay.
Because if you think about it, like those are the more relating terms, right? Comparing to weather or holiday seasons, though they might be more relating rather than combining the first month and the December, like first month and the 12th month. Every quarters will relate to each other more.
Okay.
Did you get that?
No, but I think I should start when you start explaining something. I should start writing it down because I think I can follow along much better then
Okay, then
next
you can
time.
just yeah, you can then write it now.
Um, just first, they say here this the default orientation of a single vector is a column vector in a matrix that represents a tabular dataset. It is more conventional to treat each data instance as a row vector in the matrix. Okay.
The first sentence, what they said is, if you remember yesterday, they were saying scalar matrix x1, x2, they represented it as a column.
Yeah.
Okay, though we write in language right like that, for computational purpose, it is easier to think as a row vector. So earlier the example you wrote in the Word
Yeah.
doc, right? So one
Yeah.
house data is one row. It's not a column, right? It's a row. Number of house, garage available or not, location. It's the combination. One row will give you data of one house.
Okay.
So that is a row vector. Got
Okay.
it?
Yeah.
Yeah.
Um,
Like that, we have to combine like four house data together, next four house data together, next four, and then send for training, instead of sending all the 16 or 20 together.
yeah. Okay.
Okay.
Yeah.
Yeah.
Um,
You can read me.
for example, along the outermost axis of a tensor, we can accept or enumerated mini batches of data instances, or just instances if no mini batch exists. Um, um,
I think we should like stop and get that idea onto your head. Otherwise, it will be
yeah,
difficult.
I will. I say from here.
Yeah. So we can use the same example. Anyway, they were using housing example, right?
Okay. So those the default that this is like up until here it is clear. Because like instead of saying instead of treating this here as a vector, which would just be all the location data,
Yeah.
it would be more common to use this as a vector. And then, as we will see later, this convention will enable common deep learning practices. Okay, so this is just a look ahead, and then, for example, along the outermost axis of a tensor. Okay, but I think we should really have a tensor. Like, what would be a good, like this is a matrix, but they're talking about the tensor. So, what would be a good example for a tensor?
So if you go to your Google Colab page,
Mhm.
that this tensor is there, no? You can copy the data from this.
Yeah,
Not that one. Second,
yeah.
A dot T.
Okay.
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 So again, here like there are only three tensors, right? Only three tensors, correct?
Only three tensors? Um, I first have to get used to the notation because um,
Because
this is 3 dimensions, right? So there should be a z-axis. So this one is the x-axis. Is that correct?
yes, the number of rows. So
Then this one is
four.
the y-axis.
Y-axis will be 0, 12, 24, 36, 48.
So this one, the 12, the 12 is x0, y0, and z1.
1 minute.
So,
Yeah.
so it would be like tensor x, y, z. And then this would be equal to 12.
So here 12 means the first 12, right? So It will be x0, y1, and z1, z0.
And z0?
Yeah, because first is 0, 1, 2, right? There are only three z's. 0, 1, 2.
I thought this one is the z-axis.
No, z-axis is the number of, what do you say, like um, the number of the tensor. So there are three tensors in this. So it is like the first data will be about one picture. Second data will be about second picture. So that number that is showing the nth picture is the z.
Hmm. Okay, so um, okay. Is that in your Hangouts or is it on mine?
Mine.
Okay. Um,
So the first, I'll tell you, the first 0, 12, 24, 36, 48, 3, 15, 27, 39. This is the pixel, no, pixel data of one picture.
okay, in this example, okay, you're trying. I was just talking like generally, um, but okay. So you're saying, okay, in this example, this one is the pixel values,
Yeah.
the brightness at each pixel, and it's like 5 by 4 pixel image.
Yes.
Okay.
So 5 by 4 is the dimension of the image, and there are three images like that, right?
Mm-hmm. Yeah.
So 5 is corresponding to x-axis, 4 is corresponding to, no,
Of the image, okay, but not of the tensor. Like this, I was asking about the tensor. Like you
yeah.
could
So
say this
here
tens, yeah, you
tensor
could,
dimension
yeah.
will be 4, 5, and 3, right? 4, 5, 3. X will be 4,
Which
Y will
which
be
which array are you describing as X? This
the
one, or this one?
inside one.
This one. You're describing this one as X.
Yeah.
Okay.
The outside is Z.
Okay.
Outside one is corresponding to Z. So if you see outer brackets, there are only three brackets, outer
So
brackets.
this would be actually be like this, like this.
X equal to 1. No, X equal to 0, right?
Okay. Like I'm following your
You,
lead
you
here.
are
So
you are pointing to 12, number 12, right? You're trying
yes.
to point to number 12. Yeah. So X will be in the, like 12 is in the first row. That means x-axis value will be 0, right? First row means x-axis value is 0. Because in computer it is 0, 1, 2, not 1, 2, 3, right?
But if I actually would be doing this in Python or with the Torch, then it would be like the Tensor.
Actually, we don't have to do
Tensor.
it here. We can take it to the collab, and you can just write a dot
Okay.
t and just give the square bracket and see.
So if I would have to get the
Yeah, just put a square. Just save this a dot t in some variable. Suppose say L
I
or
would just like
okay.
this. So like right.
Like 001.
It's then it's just a matter
So
of how to name this.
can you okay 001. So okay, then I think z is represented on the first one, x on the second one, and y on the third one, because the column is one, right? So if you see, column value of 12 is 1 because it's on the second column, right?
Um, I'm confused why it's not just X, Y, Z. You know,
And it's like
like
here
what?
there are three tensors.
Hmm?
Okay, in three tensors, 12 lies in which tensor? The first tensor, right? There are three tensors.
Why three? This is just one tensor here.
Um, can you give a dot t 1 instead of 0? Yeah, just give 1 and run. No, not you didn't have to yeah, see, so there are three tensors. Now you are pointing to the second tensor, which is 1, 13, 25, 37. The whole thing is one tensor. So this is the second tensor in the A.
I think we should just go move along.
No, this is actually easy. You are there, but like maybe because I'm talking too much.
Yeah, maybe you should share your screen or something.
Yeah, I'll do that.
I will get some water. Be right back.
Just enable.
Oh, it's not enabled. Okay, sorry. I thought I would. Okay, I enabled it.
See how like yeah, this is um, so how did you create that tensor? uh, 20, no, reshape.
Oh, you just have to do the 20 times 4. So in the arrange, you have to multiply the 20 by 4 so it has enough. No? What? What are you doing?
No, 5 by 4.
Why? But then no.
No.
Huh? No, like you should. Can you undo one more thing? Like, can you have the reshaped ask for 3 parameters?
I didn't get you.
Can you like go on edit in the title bar, and then oh, I thought there's no undo. Oh,
No.
you then you just
I'll
go
do
in the
control. Yeah.
yeah. One more. One more, like repeatedly. I will say stop. Yeah, like this. Why didn't you leave it like this? Oh, because okay. So yeah, why? Where is that coming from? It's
No,
from
can you just
the
can
notebook I shared with you.
no, I had to create a separate notebook so that I can write. Otherwise, like when you
Oh,
write, I won't need to write.
okay. So
Can you just share the
so
command? Like just share it in the chat.
no, you can also just the NP arrange. You can say 3 times 5 times 4. Yeah.
Okay. Yeah. So here, if you see, so there are 4 tensors now. First tensor, second tensor, third tensor, and fourth tensor. Okay.
Okay.
So this will be like first picture, second picture, third picture, fourth picture. So now
Okay.
if you want to get the details of first picture, you will give here 8 0. So
Yeah.
that is
Okay.
supposed to give 20 0 20 40, right? Similarly, if you want to get the fourth picture, 3.
Yeah.
Okay.
Yeah.
Now if you want to get the first pictures, um, like this element, this pixel value, then you'll have to give a dot t of first picture, that is 0. Then
Yeah.
here the row value is 0, right? Because it's in the first row.
Okay. That would be the
So
Y then, right?
it will be the x correspond to row, m, x
No. But if you see, like this is like the Y-axis is always
oh no,
vertically. Like
y-
X is horizontally and Y is vertically.
uh,
No, you always have the Y-axis on a function labeled on
yeah,
the.
so this is 1x, 1x, right? So and this is 1y. Okay, like 0 20 40 is 1x, 1 horizontal x, 0 4 8 12 16 vertical y, correct?
Yeah. Yeah. So the Y is 0.
Yeah, so the y is 0.
Okay.
No,
And the X would be 1 for the 20.
x would be 1 for the 20.
Okay. And then the depth would be like the, if you, the images, like if you would stack them on the z axis. Okay, so it's like z, y, x.
Yeah,
The order is z, y,
yeah,
x.
yeah. Z, Y. Yeah, correct. Okay, so
Okay, I got
you
it
are
now.
right.
Not
Yeah.
I was x, y, z, and the order, actual order
So it is
is
once again.
reversed.
It is Z, Y, X, right?
Yeah, so reversed basically.
Yeah. Okay.
Okay, I should make maybe I should make a flashcard for that.
We were actually discussing about transpose and then we went to tensors.
Yeah, but also the next section is tensor, so I think we're on a good track there. And then they, in their example, they were saying, and as we will see in later chapters, this convention will enable common deep learning practices. For example, along the outermost axis of a tensor, we can access or enumerate mini batches of the data instances or just the data instances if no mini batch exists.
Yeah.
Okay, so if I would have mini batches, I would add one more dimension. In the picture example, I would create a 4-dimensional tensor, right? So
one minute. Yeah, in the picture example. Can you hear me?
yeah.
Yeah, what were you saying? I just wanted to be on this page so that I don't miss out.
Are you on the Google Docs page?
No, I'm on the collab page. The Google Docs, you have it.
Okay, I will share the Google Docs with you as well.
Or you can share. Okay. But this itself can help, no? That now you are familiar with this. This is enough, right?
Sorry?
What I have highlighted, this is enough, right?
Yeah, for the
Picture example.
yeah, but now we're like
Now we're talking about batches and mini batches, right?
yeah, and why can't I? There's a chat. So if you open the Google Docs document, and you scroll down a bit,
Again? Yeah.
for example, along the outermost axis of a tensor, we can access or enumerate mini batches of data instances or just data instances if no mini batch exists.
So the outermost axis means this one, this bracket.
So the z-axis.
Yeah, the z-axis. So
Okay.
inside z there are 3, right? 0,
Yeah.
1.
Okay,
2,
but
yeah.
and then if we would be continuing with the image example, and we would be iterating mini batches of data, we would actually create a fourth. We add a fourth
dimension.
Yeah, for the mini batches.
Yeah, but
and then
like
the fifth dimension for the batches, right?
Yes. Fifth dimension will be like an entire new tensor, something like that. So actually, if you can see this example, and suppose these are data that we are using to classify dog and cat. Okay. So first one is a dog, second one is a cat, third one is a cat. Okay. So So similarly, there will be millions of images, right? When we are training. So those millions, we cannot push it together into a model at a stretch.
Yeah.
So we will take first three maybe, then next three maybe, like that, mini batches.
Okay.
So one mini batch will have random probability of these many cats and these many dogs.
But
Or
can't we only feed one image per, or shouldn't we only feed one image per time to the model? Like,
okay, so one image learning will take, suppose it take 1 second, right? Then you have millions of images.
Yeah.
And it will take millions of seconds to complete the training. So that is not the way it is done. They are trained in batches.
So multiple images are turned into one picture, basically.
I'm not sure how it happens in the backend, but like it is not one in, one out. It's not happening like that. We just push a batch of data. It's like,
Okay.
what I remember is like you see biscuits made in factories, like they mix a batch of flour and chocolate and cream together, and then one batch will give 10 packets of biscuits, like that. So it's not like you make one piece of biscuit, next piece of biscuit, but you make in batches, or bread
Okay.
loaf, like that. You have to think it in that way. But what happens in between, like how the batches are used by the, like analyzed by the model, that we need to
Find
dig
out.
deeper. Yeah.
Okay.
And I think like that is one big difference where each model differs. Like a ResNet will differ to a VCC, what is it, VGG, like that. How they handle batches is a peculiarity of each model.
Okay, I think this will be explained in the book how it's working in detail.
Yeah.
Okay.
Okay. So we were at mini batches, and next is tensors. 2.3.4 tensors. Just as vectors generalize scalars and matrices generalize vectors, we can build data structures with even more access, tensors. Tensors in this subsection refers to algebraic objects. Give us a generic way of describing n-dimensional arrays with an arbitrary number of axes. Vectors, for example, are first-order tensors, and matrices are second-order tensors. Tensors are denoted with capital letters of a special font face. Example, okay, we can call it like linear bold X. Okay, for a tensor. They are using a peculiar value way to represent a tensor. It's linear
Like,
and
where's the
it's bold.
difference to a matrix in the symbolism?
It's not thick like a matrix. If you look at matrix,
Oh, the matrix is bold and this one is
yeah, very
regularly
bold.
sized.
Yeah, but it is dark. It is
Okay.
dark, but it is not very thick. And
Okay.
their indexing mechanism is example XIJK. Yeah, we just did that, right?
IJK.
We
Yeah,
did that, right?
we did it with
Z by X.
yeah, and they're doing it with IJK.
IJ.
Okay. I'm just kidding, or what does it mean?
IJK is actually complex form, and in have you know about complex numbers? It's
Um,
it's in
um,
different.
yeah, I know about them, but I'm not really not in depth. Right.
Yeah, so actually in complex form, x will be represented like I is equal to x sine theta, y is equal to no, j is equal to y cos theta, like that.
Okay.
I'll type and show you. Yeah. Is it possible to draw in here? I think there are lines. The drawing is on the line.
I think we should make a short break, like a half hour.
Yeah, I'll
And then
okay, we'll just finish reading tensors and then stop, otherwise it will be in the middle.
okay.
You don't have to bother about complex numbers now. So tensors will become more important when we start working with images, which arise in n-dimensional arrays with 3 axes corresponding to height, width, and the channel axis for stacking colored channels, red, blue, and green. For now, we will skip over higher order tensors and focus on the basics.
Oh, wait.
Okay.
Can you just go back to the image with the
Yeah.
RGB?
Yeah.
So with the RGB, then it would be Y, X, and RGB, right?
Yes. Z,
Oh, okay.
Y, Z, Y, X, and RGB.
Okay. Okay.
Uh, yeah. So this example actually we did before. We were struggling with this, no? The code they mentioned here. They're just
Yeah.
reshaping it, and they are
Oh,
this is the
okay.
tensor. Like we have two tensors here. One is this, and next is this.
Yeah.
And can you tell me like what will be the Z, Y, and X for 23?
For image example,
Yeah, this one. I'm pointing at it now. This 23. For this example, X.
it would be wait, just the other way around, Z, Y, X. So it would be 1,
Yeah.
2,
2.
1, 2, 3.
Yes. Correct.
Okay. Okay.
Okay, then we'll
Yeah.
next
It's
we'll meet
it,
at my
I just
10:30.
yeah, I
Okay.
just noticed even for these like um even for these simple things, right? So it's first it's difficult to really understand it and to like actively use it, like, and then you challenged me, and then it was a bit like tricky to like even a bit tricky, even though I fully understood it before. So yeah.
Yeah,
Okay.
I'll just like one example I can show you. I was struggling with a project here. Oh, it will take. I was actually using images, and then this tensor was coming, so I got used to it now. 1 minute. I hope like this that won't confuse you more. But since you got the idea of image, I think this will be the right time to show. Next we'll meet at your 7, right?
Um No, actually, I thought we just do a half-hour break.
Okay, so that will be my 8:30,
Yeah.
or maybe
Also, no one is
well,
joining for the 8 p.m. schedule, but I think for the next meetup, we'll just use the link for the 8 p.m. scheduled.
okay.
Yeah, and then let's call it a day now, and then see you again in half an hour.
Yeah, just this one.
Yeah.
Here, like they were, if you see, this is the complete representation of a um, image 0525. This is the RGB,
Okay.
and oh, this thing I
Is that
think
course you're doing there? Is it for free or?
this I got because I applied for a scholarship through Udacity, and I did
Mhm.
a 2 month like we have to take their initial course, interact with their community, do projects, and in the 3 months of course, if you perform well, they will
Yeah.
give you the next course. So today, actually, Microsoft Azure has started a new scholarship with Udacity, using machine learning with Azure. So
Okay.
if you can, I'll share you the link. If you can apply to it, in another 15 days, they'll let you
No,
know if
no,
you have.
I don't like this because I don't like big companies interfering with this. I like this book because it's open source.
Okay, no, because like this is Intel's one infrastructure to run deep learning models in
Okay.
OpenVINO. They call it OpenVINO. So similarly, I've done with Amazon SageMaker. Yeah. So,
Yeah, I like the open source approach. Like,
but for running these GCPs, we don't have an open source environment, right? So when you want to actually work to deployment and all, you need to know about such tools.
well, the Colab is for free as well.
But Colab, like I try to attend one of Kaggle's, what is it? Uh, what is it? One competition I try to attend in Kaggle, and I try to bring the data to GCP, but no, Google Colab, but it doesn't support well. Like after some time, because after 1 hour of running, it will stop. Colab will stop. You
Yeah.
might have to train like for 3, 4, 12 hours and all, then
Hmm.
Colab won't work. So
Okay.
if you know some of these Amazon
Mhm.
SageMaker
But
or
there's also you can also apply for free TensorFlow units. Tensor
yeah,
for free. There's an
yeah,
application
that they
form.
give Google Cloud products, like, right?
Yeah, something like that. I don't know. It's I think it's on the TensorFlow side somewhere.
Yeah, that is there. Okay, then we'll meet back at 8:35 my time. That will be your
Yeah.
another third. Okay, bye.
Bye. Thanks.
Thanks. Stop sharing.